Hello, it's Miss DeLulo here, and today we are going to be writing equations of parallel and perpendicular lines, and that is our goal for today. So by the end of this video, you will know how to write equations of parallel and perpendicular lines in slope-intercept form. So two lines are considered to be parallel if they have the same slope. So let's look at an example of the same slope. Remember that the word m means the slope. So if we're looking for the slope that is parallel to 4, then that would be the exact same, which would be 4. Perpendicular lines are considered to be perpendicular if the product of their slopes are -1. In other words, they are perpendicular if and only if the slopes are opposite reciprocals. So let's take a look at what that means. So if the slope of my first line is positive 2/3, then that means my slope perpendicular to a line with the slope of 2/3 will be, first of all, negative because my original was positive. That's where the opposite comes in. And the reciprocal of 2/3 is 3/2. Let's do another example. If my original slope is -4/5, then that means my perpendicular slope must be positive. That's the opposite. And the reciprocal of 4/5 is going to be, just switch those around, 5/4. And finally, if my original slope is a -7, then my perpendicular slope will be positive. But how do I make a reciprocal out of a whole number that is not originally a fraction? Well, it actually is a fraction if we write that -7 as a fraction over 1. So now I can take the reciprocal of -7/1, and the reciprocal of that is 1/7. In this case, it will be positive because my original slope was negative, so the opposite is positive. So let's do an example where we write the equation of a line in slope-intercept form that satisfies the following set of conditions. So our first example is we want a line that passes through the point -6, -6, and is parallel to the original line y equals 4/3 x plus 8. So in order to do this, we are going to use something that we learned yesterday, which is point-slope form. So point slope form, as you remember, is y minus y1, which is equal to m times the quantity of x minus x1. So that means that we need two things in order to be able to use point slope form. We need a coordinate pair, which is an ordered pair, x1, y1, which is represented by our -6, -6. We also need an m. So remember that if our new equation is going to be parallel, then that means our slope is going to be exactly the same as the original. So our parallel slope will be 4/3 as well. So let's start plugging into point slope form. So anything written in black never changes, so your y minus will always be there. Now we're going to plug in y1, which is -6. So y minus -6 is equal to m, which is positive 4/3, times x minus and x1, which is also -6. So let's do a little simplifying. Y minus -6 minus a negative turns into a positive, so we have y plus 6, which is equal to 4/3 times the quantity, again, of x minus negative turns into a positive 6. Okay, now I'm going to have to simplify even more, and what I'm going to do next is to distribute that 4/3. So everything on the left-hand side stays the same so far. We haven't touched that yet. So y plus 6 is equal to 4/3 times x is 4/3 x. And now I need to multiply 4/3 times 6, which in order to do that, I'm going to make 6 a fraction over 1. So now I know that my tops multiply together and my bottoms multiply together. So 4 times 6 is 24 over 3 times 1, which is 3. I can simplify that just a little bit before I continue. So y plus 6 is equal to 4/3 x plus 24 over 3, which is 8. Okay, now I need to do one last thing, and that is notice that in the original problem we have to make sure that our final equation is in slope-intercept form. So that is your y equals mx plus b. So I'm going to take this equation and move it over here just because I need a little bit more room. And I'm going to make sure that y is on the left-hand side of the equal sign by itself. So in order to do that, I'm going to subtract 6 from both sides. So that zeroes out 6 on the left. So y is now equal to 4/3 x plus 8 minus 6, which is 2. So finally, my equation of the line that is parallel to the original is y equals 4/3 x plus 2. In our second example, we're going to write the equation of the line that is perpendicular to an original equation in slope-intercept form. So before I determine what my perpendicular slope is, my equation needs to be in slope-intercept form. That is where we pull our perpendicular slope from. So in order to do that, I'm going to start by subtracting 2x from both sides. So I have y by itself on the left. 2x minus 2x is 0, so I have y is equal to minus 2x will just get slide right in front of that 3, and since the 3 was originally positive, then this will be y equals 2x plus 3. Now I am able to continue on and to use point slope form, as you can see, to find my equation with a perpendicular slope. So again, in point slope form, I need two things, a point and a slope. So my point, first of all, my slope is going to be the opposite reciprocal of -2. So that means that my perpendicular slope will be a positive because the original was negative, and now I need the reciprocal of 2, which is 1/2. So my slope is positive 1/2, and my point, as I labeled, will be the coordinate 4, 2, as I labeled x1 and y1. Now we have everything we need to plug into point slope form. So we have y minus, that always stays the same, y1, which is 2, is equal to, now we need to insert our perpendicular slope, which is positive 1/2, times the quantity of x minus, and then I insert x1, which is 4. Now let's do a little simplifying. I need to distribute my 1/2, so I'm going to first make everything in the parentheses as a fraction, because as you multiply fractions, you multiply straight across, numerator to numerator, denominators to denominators. So that just helps me keep things straight. The left-hand side stays exactly the same. We're not doing anything to that yet. 1/2 times x is 1/2 x, minus 1/2 times 4 will be 1 times 4, which is 4, and 2 times 1, which is 2. So minus 4/2. Now to continue on, I'm going to simplify just a little bit. Y minus 2 is equal to 1/2 x minus 4 divided by 2, which is 2. Now I have one last step to finish this off, and that is to make sure my equation is in slope-intercept form, so y needs to be by itself on the left-hand side. So I'm going to add 2 to both sides, and actually what happens, since on the left and on the right I have a minus 2, those both zero out. So my final equation of the line is y is equal to 1/2 x. Now if you will flip this over, you can try these examples on your own. The answers are provided on the right, so make sure that you write down any questions that you have in that sidebar so we can talk about them in class tomorrow. As always, thank you for watching, and we will see you tomorrow.